So now what we're going to learn about is the z-score. And so here's my definition of a z-score. The z-score is the number of standard deviations, xi, a certain data point in a data set, xi, is from the mean. So the number of standard deviations a data point is from the mean. And we calculate that by taking that data point, subtracting it from the mean, and then we divide it by standard deviations right here. So let's remind ourselves what standard deviations are. We just did a little review in the previous video. But here you can see that for this data set right here, the standard deviation, the amount that the data deviates or varies or changes in the data set is 2. And that really plays well with this data set right here, because you can see that our mean is 10 and that the data will vary by 2. It'll either be 12 or 8. So the standard that the data varies or the data deviates is 2. The standard deviation is 2. So this really nicely aligns with this example right here. But again, standard deviation is a numeric measure that's a descriptive statistic. And so it gives us some insight. It describes, it's a descriptive statistic. It describes what's going on with our data. So here 2 really kind of makes sense because of the example. We could really clearly see that. Over here, the descriptive statistic of the standard deviation is 11.59. So our data in our data set is more scattered. And when we calculate what is the standard deviation of this data in that data set, we get 11.59. So it's a numeric measure, a descriptive statistic that gives us insight into the variation, the dispersion, the deviation. You could use these words to talk about how's the data scattered, right? It gives us insight into that. That's what that numeric statistic, the standard deviation, does. So now let's figure out, so that's for all of the data. That's for the entire data set, right? This is like what's the standard deviation of the data set? That's what it is right there. It's 2 or it's 11.597. That's for the entire data set. What about for each data point? For each data point, we could calculate a z-score to see how far each data point is away from the mean. How many standard deviations is each data point away from the mean, right? So the number of standard deviations xi is from the mean. And so mathematically, right, that's exactly what this mathematical formula says right here. You take the data point, you subtract it from the mean, you get some value, you divide it by the standard deviation for the entire data set, and so that will give you the number of standard deviations or the fraction of standard deviations that a data point is from the mean. So let's calculate that. And to calculate that, I'm going to insert some rows. I'm going to highlight all those and insert 3 columns to the right. And then I'm just going to put, I'm just trying to figure out what I want to calculate here. So we have the data point minus the mean. So we already have the data point minus the mean. So here's the data point minus the mean is -2. So I'm going to put up here z, and I'll make that bold just to make it stand out a little bit more. And now to find out what is the z-score, what is the z-score for each individual data point. To find that z-score for each individual data point, we're going to take the difference between that data and the mean, which is -2, and we're going to divide it for that one data point xi right there. We're going to divide it by our standard deviation, and we're going to hold that standard deviation absolute. We're going to hold it constant. So as we drop this formula down, it'll reference the xi minus x bar value right here for each data point, and then it'll divide that by the standard deviation for the entire data set, and that will give us our z-score. So I'm going to come up here and Control C and then highlight this and Control V, and there's the z-score for each data point in the data set. So that's interesting to look at. I'm going to delete this column. I don't need it. Delete that column. I wasn't sure how many I was going to need. And what did I just delete? I don't want to delete that one. I want to delete this one, delete that one, delete column. And we'll just make this one a little bit smaller just to kind of separate the data. And then I'm going to come over here and I'll insert 2 for this one. And to do that, I'll do that. I'll select this entire one here and then select that one and then right click it and insert 2 columns to the right. And then I'll make this one a little bit smaller, and I guess we've got a separator right there, but anyhow. So now we will do this here. We'll get the difference between this data point and the mean, which is right there. and that gives us 20, and we're going to divide 20 by the number of standard deviations, and then we'll make that absolute. And then we'll hit enter on that, and now we'll copy this. So Control C, and we'll copy this one down, Control V, and actually I'll get rid of this column here just to keep things. Oh, not that one, got rid of both of them. I just want to get rid of this one, get rid of that one here, delete column, there we go. And now for the final one, and I'll just bring this over a little bit here and bring this over a little bit here, just bring my data, all my stuff in so it all fits a little bit better. There we go. And so for this final one here, I'm going to insert and do one more column to the right, and then I'm going to do my z-score here. So I'll copy this over, Control C, and there's that, Control V, and I'll format these. I'll come up here to Format Data, highlight them, and Format Number, and I'll do a custom number format. And I want to do 2 decimals, so I think that just goes in as 0.00. Whoops. 0, and I don't need my coding stuff up, 0.00, and I'm going to hit apply on that, and so there's two decimal places. And you can look through those different formattings, what you just saw me do with formatting numbers. You could look through like the different formattings and start to get a sense for how they work, so you could start to enter custom ones. And then for this one, I'm going to take the difference between each data point and the mean, and that will give me this one, and then I'm going to divide that by my standard deviations, which is this one. I'm going to hold that constant. I'm going to press enter there, and I'm going to copy this one, Control C, and then paste this down, Control V, and I'm going to highlight all of that, and again go over here to format and go to number formatting and go down to custom number format, and I'll put in the 0.00 to 2 decimal places. It gives you a little preview of what that'll look like right there. And so there are the number of standard deviations, or the number of deviations, the number of standard deviations each data point is away from the mean. So again, mathematically what you're doing is you're just figuring out like, okay, how far is this data point from the mean? It's -2. All right, let's divide -2 by our standard deviations, and it'll tell me how many standard deviations this data point is from the mean. How far is this data point from the mean? It's 20. All right, let's divide 20 by the number of standard deviations, and it'll tell me how many standard deviations this data point is away from the mean. Why is this useful? This is useful because it allows us to gain insight into our data points, and we could see if some data points are real outliers, right? Like if they are more standard deviations away from the mean than the other data points. And so when I look at this one right here, 1.72, that's further away from the mean than in standard deviations. It's 1.72 standard deviations away from the mean, right? That's further away than any of the other points. And so that might be something that I'd want to look at. Generally speaking, you don't consider something to be an outlier, like really, different and really outside the collection of data, an anomaly almost. You don't really consider a data point to be an outlier unless it's 3 or more standard deviations away from the mean. So that's how you calculate your z-score. And your z-score shows you the number of standard deviations a data point in the data set is from the mean.